Okay, so let's make sure this is recording. Okay, good. All right, so I'm going to talk about how I can write an equation for these transformed uh, power functions, these transformed x squared functions. So remember, normally the nx squared, that toolkit function y equals x squared, has a vertex at the origin. And when they go over 1, they get squared, so it's up 1. If they go over 2, it gets squared, you go up 4. Same thing off to the left, because these are even functions. So we're going to keep that factoid in mind in order to write these transformed equations, these transformed parabolas. Also, you got to remember that for any transform function, the a is the vertical stretch. If there's some kind of horizontal compression, that's inside, and it's x minus, we'll call it h, can be c, whatever you want to write, plus k. So this is the up-down shift. This is the left-right shift. That's some kind of horizontal stretch or compression. This is some kind of vertical stretch or compression. And if that leading term is negative, then it's been reflected around the x-axis. If this inside here is negative, it's been reflected around the y-axis. Of course, for a parabola, it doesn't matter because they're even. They're symmetric with their axes, the symmetry, actually, as we call that. So let's try writing an equation for this parabola here. I'm seeing a vertex at 1, 1. So I know it's going to be y equals x minus 1 for the right shift, and it's squared. Then it's up 1, so plus 1 on the outside. And then I'm seeing, talk about vertical stretching here. Let's see, over 1, up 1, over 2, up 4, it looks like. So I don't think this has been stretched vertically at all. I think it's just y equals 1 times the, that left-right shift and up-down shift. So I think that's easy enough. So now for this one, I'm seeing a vertex at 2, 7. So that tells me the function's been shifted to the right 2, up 7, and then I get to decide if it's been stretched vertically. Well, I do see it's been reflected around the x-axis, so there's got to be a negative there. And when I go over 1, I'm going down 2. So that looks like it's been stretched by a factor of 2. If I go over 2, am I going down 4? Nope, it looks like I'm going down 8. So it has been stretched by a factor of 2. So that is the transform function for this one. And in chapter 3, section 3.2, we'll learn more other ways to do the same thing, depending on the equation or other things I didn't tell you. But it's all based on what we know already from way back in chapter 1. So hopefully this helps you remember how to do this when I ask you to.